Common student ideas, the free particle model. Hi there, thanks for joining us. We're here to talk about common student ideas, and the common student idea I was selected to talk about was the free particle model. A lot of students have trouble with the free body diagrams. Basically, students don't always get free body diagrams. They have a lot of trouble with the normal force. They're not really sure what goes, what arrows point in what direction when drawing a free body diagram and that stuff. But I thought, like, who better to have than to explain force than none other than a force expert, Jean-Claude Van Damme. JCVD! I'm glad you could make it. Are you happy to be here? No? Alright. Not even a little bit?
No!
Okay. Alright, let's get to work. So one of the common student ideas is that, for example, let's say a box just sitting at rest. Okay, so how do you draw the forces on that? Well, they don't realize that there is both a gravity potential and a normal force both acting. In order to understand this problem a little bit better, let's just picture JCVD just standing there. Alright, so he's just standing on the floor at rest. Let's give him something to do. Let's say he's defusing a bomb.
I'll defuse the bomb. You go save the girl.
As he's standing there, the feet on the floor, there's a gravitational potential trying to pull him downward into basically the center of the Earth, and there's the atoms that take up the core of the Earth that are pushing back on him, so that way he doesn't go anywhere. And in this instance, there's no net force, so he is at rest, and that leads to a common student idea where if something has a constant velocity, they still don't have a net force. For example,
it's done!
JCVD defused the bomb, but it turns out he didn't actually defuse the bomb. He made a mistake, he pressed the wrong wire, so it ends up blowing up anyway. Yep, okay, so then now he's just hurtling in space. So in this free body diagram, JCVD has a constant velocity flinging through space, but nothing else is affecting him. So a common student idea here is to illustrate a force in the direction of his motion, but as it turns out, there's no net force because there's no acceleration in any direction, and basically it's inertia. He's just floating, he's hanging out. How you doing, man? You doing all right, JCVD? Yeah, I don't really. Okay, all right. So he's not a fan of this kind of stuff. Whatever, that's fine. Alright, so another common student idea is, for example, let's think of a scenario. You roll a bowling ball, right? And you roll it on the floor, and then you give it a sort of a swift kick, right? And what the idea is, you want to be able to hit it 90 degrees to its motion. So you want to give it a hard, sharp left turn, right? The thing is that when asked to draw a force that could do this, the common student idea is to indicate a force directly 90 degrees to the movement. Now, let's say Jean-Claude Van Damme is kicking a ball, right? So he likes to kick bowling balls. He actually does it a lot. He practices quite often, he tells me. JCVD kicks these bowling balls at a hard, sharp turn. Now, in order to do that, he actually has to kick it at a slight angle to counteract the velocity going in the forward direction. You can't just hit at a 90-degree angle, right, JCVD? You just can't do that, right? It's just like against the physics rules, basically. You just can't do it. For my final common student idea, as a sort of fourth example, is that let's picture it's a common man on the side of a mountain scenario. Okay, so let's just say that he's on a cliff and hanging from a rope and just shooting wildly at, I don't know, there's probably a bad guy somewhere. Or maybe they're just in his mind, but he's just shooting his gun on the side of a cliff, alright? He's dangling from a rope. So, think about, how to draw the forces on this. Well, there's the force sort of pulling him down, right? There's this gravitational force, and sort of a common student idea is, it's not immediately easy to know where the forces are coming from. So, there is, of course, this force here that will draw arrows in this direction because they're like, well, he's sort of facing on that, but the correct way to draw it is, putting an arrow this way, and so you see it's the normal force is the wall pushing up against him, and that's at an angle with the force that's pulling him down, of course, that matches this rope here, and that is the tension. It's not immediately obvious how tension works with normal force and gravity on that side. So okay, so I think you can stop shooting now. I think he's got to be out of bullets at some point. I guess not. I don't know. He's an action star, so it's alright. We should look into that. Thanks for joining us for this Common Student Ideas seminar. It's very business professional like. If you want a business card, just let me know. I can get you a business card because I have those. JCVD, thanks for joining us. Do you have any? I don't know. Do you have any thoughts?
Do you like sushi?
Yeah. Okay.